Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you. We are continuing with our journey on the use of Landsat daytime imagery. Um, Following on from our previous tutorial where we explored the five, which I think is the five main data sets in the Landsat series, which is Landsat 5, 7, 8, and 9. Remember, we we put emphasis on the fact that the Landsat 5 and 7 are very similar in terms of its bands, i.e. from band 1 to band 7, whereas Landsat 8 and 9 again is very similar in terms of its bands, and there's quite a difference between the 5 and 7 bands and the 8 and 9 bands in the sense that 5 and 7 starts on the blue with band 1, whereas 8 and 9 starts the blue in band 2. So always when you have 5, 7 on the one hand and 8 and 9 on the other hand, make sure that you understand that there is a difference, especially when you do the presentations or the visualization of those images from the different Landsats. So just quickly, just to refresh ourselves, we go to our trusted Earth engine, we go to our data sets. On our data sets, we'll find a ribbon, and on that ribbon, we simply just click on Landsat, and that will take us then to the landing page of all the different Landsat data sets. Remember, in my case, I'm just using 5, 7, 8, and 9. I don't use 1, 2, 5, 1, 2, 3, and 4, although you're more than welcome to play around with this. Just quickly refreshing, remember, if we click on the Landsat dataset name, let's click on Landsat 5, it will take you to its landing page, and from there, remember, we work with the surface reflectance images, and specifically tier 1. Same with Landsat 8, we go to Landsat 8, same surface reflectance and tier 1. So just to quickly inform you guys again that there we can see band 1 is blue, the blue band. In Landsat 5 and 7 and an 8, the blue is in band 2. Okay, so just remember it. And again, at the bottom of each landing page, you'll find the script to start um, the process of acquiring the images. Okay, so you basically either copy and or copy and paste it as per my previous tutorial. Okay, so if you're not up to date or don't know how to do this, just go and consult my previous video editor on the Landsat. Okay, so fast forward, just make this a little bit lower. There we've got. Okay, so went to my script column and I found my project that I'm working or the script that I'm working. I double click and it opens up. Remember again, I'm not going to go through the first ones, but my region of interest I loaded. I'm going to display my region of interest. I've centered it around and I've got my clip. Remember, with the Landsat series, there's some scaling that we have to do. Remember again, 5 and 7 use the same scale, 8 and 9 use the same scale. It's all in the difference between the bands, as I said. Okay, so there's our script to acquire our Landsat 5 image, our script to acquire a Landsat 7 image, our script to acquire a Landsat 8 image, and our script to acquire a Landsat 9 image. There's our scripts to display the various Landsat images. Now, just bear in mind that I have filtered each image to capture the full duration of that specific time series. So in the Landsat 5 case, the duration is from 1985 to 2011, 2012. If you're not sure, go back to your Landsat landing pages and you'll see there is the data availability of that specific data set. Okay, so from 1984, so I'm not going to do 1984. I'm just going to go straight to 1985. But it basically captures all of the images that Landsat 5 has generated for my region of interest, whether it's 20, 30, 100, 200, we don't know. But yeah, there's going to be numerous images within this collection for this time period. Okay, so I apply my scaling factors as per the code above, and then I generated a single image which is based on a median statistic. So let's say there's 100 images in that time frame in my collection. Then I'm going to take that 100 images and I'm going to create a median image for those periods, and it calculates the median value per each pixel, and that will become then the image. Okay, so remember again, you can change these dates. Okay, I'm just arbitrarily using the entire catalog of images within that image collection. You're free to change it. In fact, it doesn't make sense to use it because you want to create a time series from band 7 to band 8. So you want to create unique values where there's no overlaps. And you can see between Landsat 5, which ends in 2011, and Landsat 7 that starts, is 11 years of overlap. So ideally, you don't want this. But for illustrative purposes, let's proceed. There's our visualization parameters, and I'm using the true color parameters. Okay, there's different color schemes in each Landsat or Landsat data set in terms of the combination of bands and then the colors for each band. Okay, so using bands at 1, 2, and 3, or 3, 2, and 1 in this case gives you a true color image. You get false colors, you get all sorts of colors. We're going to play around with this a bit later. Same with Landsat 7. There's the entire catalog of images in that collection. I'm creating again a mean one after I've applied the scaling factors, and there's the bands that I'm going to display, and it's again the true colors. There's Landsat 8, same thing, unique identifier, that all the images in that, which is still current, remember Landsat 8 is still current, scale factors, and calculate the mean one. There's a true color. Remember, the true color is not 321, but 432, because on bands at 8 and 9, band 1 is an aerosol, a deep blue one, which is not available in 5 and 7. And the same with Landsat 9. Okay, and then I'm going to display my images that I've created, my medium images. Remember, medium images for those periods, and it's clipped to my region of interest. Okay, so there's my codes. Let me just make this a little bit. There's my script. Let me do that. Okay, and then once I've done it, remember to save and to run. Okay, save and run, save and run. Always save and run. Okay, so there they are. Okay, all allocated into my layers panel. There's the layers. Let's unclick and start from layer Landsat 5. There's Landsat 5, true color median. There's Landsat 7, true color median. There's Landsat 8, true color median, and Landsat 9, true color median. So the first impression is that there seems to be subtle differences here and there in the region of interest. But in general, if we just, let's say 5 and 9, you can see that it's just basically the colors that either get a bit darker or lighter, but doesn't seem like there's major differences. But we need to understand that we're very, very big region of interest. So differences will almost be blurred out, or small differences you won't be able to pick up, simply because it's such a big region of interest that we're displaying at a very, very small scale. Okay, so ideally what we want to do is we want to zoom into a particular area to actually see whether we can visually detect changes, anomalies, things that stay the same, etc., etc. Because this is quite a long period of time, and this is where your choice of the time periods are so important. And and you don't ideally want any overlays, because then you sort of neglect, or you cancel out the changes, or you won't be able to see the changes, because if there's overlaps, they're basically displaying the same things. So let's zoom in a little bit and see if we can visually detect any specific changes. Let me just quickly open up these things. It will take a bit of time to load now. Let's see, hopefully it goes quick for it to load. In many cases, it does take a bit of time for these images to load properly, especially if it's such a big region of interest that is in my case. Okay, so it is slowly loading. While it's loading, as I said, remember you want to have your time periods in such a way that it has unique features for that particular period. And that's why you don't want to overlay it, because as soon as you overlay it, basically you harmonize or you diminish that unique features for that specific period of time. Now, this is quite relevant when we look at, for example, urban change or land use change or land use patterns, specifically when we're going to do classification, whether it's supervised or unsupervised classifications. Okay, so, so let's continue while this thing is loading, and it's basically loaded a Landsat 5 image, and it's busy loading the Landsat 7, 8, and 9 images slowly but surely. Um, let's quickly, that's Landsat 5, Landsat 7 is still busy loading, Landsat 8 is still busy loading, Landsat 9. Okay, so while we're looking at, let's have a look at 5. We can see a settlement here. We can see some urban activity around here. This looks like a mining facility here. This is an Air Force base there. There's the harbor, coastal areas. Um, there's another mine there. There's some industrial development happening around this area. This is in fact a station, a railway station. As I said, there's a city. So this particular image covers quite a lot of man-made activities. This looks like a golf course that's located in this specific area. There's some roads that's visible that you can see. The rest looks like farmland, agricultural land. Um, and remember, this is also a sandy area, so you'll have lots of open sand locations, which is important to remember because sand and urban areas, in terms of its spectral identity or spectral signature, is very, very similar. Okay, so let's have a look and see where we are now. Okay, so that's Landsat 5. Landsat 7 is still busy loading. Landsat 8 hasn't loaded. Landsat 9. So let me pause this for now until these images have been loaded, and then we'll continue. Now that all 4 images have loaded, let's have a look and see what we can figure out. Okay, so that's our Landsat 5 image. Let's have a look at Landsat 7. Let's have, okay, looks particular at this particular area here that I'm displaying now. You see there's Landsat 5, then Landsat 7. You see there's some developments happening around this particular area. And let's see, this mine area seems to be have expanded. In terms of our urban area here, let's have a look and see. Yes, there seems to be some areas around this particular area. And then obviously around the outer edges, you can look at this particular area here. Look at Landsat 8. You can see here some developments occurring, but you get the gist of it, and it's specific here as well. But I think you get the idea of the Landsat. It is impossible to identify land use, land cover changes, and so forth and so forth. Okay, so that's quite interesting. But yeah, so this is displaying these images in what we call the true color, which is 321, 432, bands 8 and 9, and 1 and 321 in band, Landsat 5 and 7. But let's say we want to play around with these colors. Okay, so let's, for argument's sake, let's say we choose Landsat 8. And you can do this with all of the Landsat images. So we go to this little cock, or whatever you want to call it, and we're going to get the visualization parameters. Okay, same as we did with the night light time series, nighttime light time series. Here we're just going to do it with the Landsat. Remember, now we've got multiple bands. Okay, not just a single band where we had average radiation of average visit visualization. We're going to, here we do it, multiple bits. You can display this in single band, no problem with that. And we're going to do that a little bit later. But let's, for example, first stick with our true color 432 in Landsat 8. There's our range as we've displayed the range in our code. See, there's the range, minimum and maximum, minimum and maximum. Okay, so we're gonna can play around with this. We can add colors to it, all sorts of things. But let's play around with the minimum and maximum. So we're gonna stretch these images to see if we can make these images look a little bit better or more appealing. So first one is let's stretch it in that way. So there is the stretching now applied. You can see the range have changed. It's not from 0 to 0.3. It's now from 0.08 to 0.13. We press apply and let's see what this image will look like. Okay, so again, it will take unfortunately a bit of time. So let's pause quickly. Okay, there it comes. Okay, so you can see the visualization is very different than the true color visualization parameters that we initially um, puts forward. You can see that it um, like I call it man-made or urban structures and specifically soil gets a very yellowish color and then dark vegetation areas is very black. So this actually highlights um, remember this is a mine here, it's quarry mine. um, so this highlights sandy patches, let's call it non-vegetation areas. You can see there's the runways of the Air Force Base there. And then if we just put a satellite image there and we overlay it with that specific satellite image, you can see there's the mine. If we go and activate Landsat, you can see the mine, and these are roads. Let's just quickly have a look and see sequence roads. You can see the railroad crossing and these developments. Let's have a look at these dark areas. You can see they are high vegetation areas. You can look at this area. Let's have a look there. This area here. Have a look at that. Okay, it's not yet colored, but you can see this particular, look at that area next to the mine, and you can see it's very dark. So this gives you a light yellow, a light orange, dark white when it's just sand, and then going up to a dark black, which is high vegetation, and then obviously all the colors in between. Okay, so you can see the um, area there as well. So okay, let's go to the second option, which is this stretch option, and you see it has stretched the range, the minimum and maximums. Let's press apply and see what this image looks like. Now again, many cases it will unfortunately take some time, so unfortunately we have to be patient. Okay, so while this image is loading, at least it's loading where we can have a look. You can see this is now presenting it, and again in a very different light, in the sense that it's not that dark red or dark white or dark black colors. This is more a brownish color scheme that it is displaying. But again, you can clearly see the mine and the high vegetation areas versus the sandy areas, and then obviously also the urban settlements, etc., etc. So let's go to the next one, which is this particular option, and it will again basically stretch it in terms of a new range of a minimum and maximum. So if we press apply, let's see what this image looks like. So this particular visualization parameter looks very similar to the true color image that we've presented initially. So yeah, so this doesn't really add much, except I think that it just highlights the man-made areas a little bit more than the true color parameters. But yeah, so that's that option. Let's go to the stretch 90%. You can see again the range have changed. Let's press apply and see what this comes to. Okay, so this is this particular image in terms of its visualization parameters. Now, obviously, the smaller your region of interest, the quicker these images will display. So just bear that in mind. Keep on enforcing that my region of interest is quite large. So that's why it's taking a bit of time. Anyway, so this is its visualization parameters. Again, not too different from the true color scheme as what we originally coded, but you can, again, interesting to see the differences in the land use, land cover in terms of high vegetation areas, typical farmlands, agricultural areas, urban areas, industrial areas, mines. These sort of areas are fairly easily identifiable using the Landsat images. And you can, let's use the remaining two. We still have a bit of time, so let's display the last two parameters, which is the stretch 98. And again, all that these parameters do is it influences the minimum maximum point, i.e. the range of the values, the minimum and maximum values for each pixel. So that's the only thing that it does. It's not much different than if you actually change it. And this is basically, if you decide, let's say you decide that this particular visualization is the one that you want to present in your Earth engine, then you simply just in your code, in where it's minimum and maximum, just change the values in your code with the values in your visualization parameters. Remember, this is the minimum value, and that's the maximum values. Okay, so all you'll do is you change it to that specific numbers, or you can just simply press import. In fact, let's quickly say we want to do this one, so we'll import it. Okay, so it will now display on top here. You'll see there's the visualization parameters. You'll see there's the minimum value that we've presented there, and the maximum value 0.2702, and the minimum value 0.2 blah 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 blah. And so you can simply just copy and paste that piece of code into this, or you can just call it your visualization, whichever you want to call it, and then in your where you add your layer, where you visualization parameter, you change it to the name that you're going to give it up here. So when you're displaying it, it's not going to display it in where you originally had the visualization parameters. It's going to display the imported visualization parameters, which is what this is. Okay, so that's what you will be able to do. But remember, just in terms of the references in the code itself. So there's a 98%. Let's make it 100%. You can see subtle differences in the minimum and maximum. If we press apply, the new color scheme or visualization image will then appear in your layers. Okay, you can play around with opacity, which is basically just the transparency of it, and light and dark colors. In gamma, you can also play around. Sorry, opacity is transparency basically, and the gamma is lighter colors or darker colors. You can again play around with all these. So what this allows you to do is just to play around with in our case, band 4, 3, and 2, in terms of the range in these bands from regarding the minimum and maximum. And this gives you a nice way of visually presenting your true colors if the original scheme, is not that good to identify land cover or land cover chains, etc. Okay, so let's say we want to go to remember our first stretch option is where it gives us this very, very dark, um, bright colors in terms of from yellow to red,
where yellow or white is sand, and then yellow is sandy areas, and then high vegetation areas are dark black colors. If we zoom out for entire region of interest, it will again take some time to load for the whole image. Let's give it a couple of seconds. Okay, now that our visualized image has loaded, it's possible to present it for the region of interest as a whole. And you can see these areas of where it's white, and then dark or bright yellows changing into orange colors, into dark reddish colors, into these black colors. Remember what we said, that if we let's quickly have a look and see where this whitest areas. You can see this is sandy areas here. You can see that, and it displays in that specifically white and yellow colors. And then if we look at the dark red is more farmland. You can see these particular areas, or light vegetation areas, for example. And you can see these are mountain ranges where you have high vegetation, similar to this, which is a nature park, etc. So this is a nice way of presenting the Landsat. And again, you can import these color schemes into your script, and you don't have to redo this. Okay, so we've basically only looked now at the true colors 432 band. Obviously, all the bands are available. So in the next tutorial, we're going to play around not with the minimum and maximum value, i.e. the stretching function. We're going to actually play around with the band, different combinations of bands to see what that visualization looks like. And obviously, as you change the combination of the bands, you can also change the stretching of that particular combination of bands. So there's n times so many options that you can actually play around with to determine what you're interested. If you're interested in sandy patches, then this is most probably a nice way of presenting this. If you're looking at water, then there's different ways of that, or if you look at urban areas, etc., etc. So yeah, so again, it's up to you. Play around with this and see what comes out every time you change these options. Remember to continue to apply. Once you've made a change, apply. Give it some time for the whole image to load. If that's your image, that the parameters that you're interested, you basically just use the import function, or you just manually change the code within your visualization parameters, the visualization within your code to reflect these parameters. Okay, so yeah, I hope and trust you've enjoyed this particular video tutorial. Uh, Thanks for joining me on this remote sensing journey, and I'll see you on the other side.